Alright, so now we're going to look at a graph problem where we have to analyze the graph given the first derivative. Um, so there's 5 parts here. First of all, part A says find where the function has a horizontal tangent. So you always need to keep in mind that this is the derivative, so we need to look at where does the derivative equal 0. So the function itself would have a horizontal tangent. Looks like when x equals a -4, looks like it crosses again at x equals 2, again at x equals 4, you can see it's 0 here, and then again at x equals 8. So those look like the horizontal tangents. So part A is going to help us with part B. We need to find out where we have a relative max or relative min, and perhaps drawing a sign chart might be helpful. So we can just set up a -4, set up 2, set up one at 4, set up one at 8, because those are the horizontal tangents, or where the first derivative equals 0. And we can just look at the sign of the derivative. So here to the left of -4, the function itself is positive, so that means it's increasing. We know it's 0 at 4. Then it looks like it does what? It turns to negative, and it stays negative all the way until we get to 2, where it's 0 again, and then between 2 and 4 it's positive again. Okay, so we have a decreasing here, and we have an increasing portion there. At x equals 4, it switches from positive down into the negative world, so we have negative there, so the function is decreasing. And then to the right of 8, it looks like it's continuing to increase. So we can use this to take a look at a few of these. So if something goes from increasing to decreasing, it's going to do something like that. So we have a relative max. So we'll just list our maxes over here. We have a max at x equals -4. And where else does that occur? Looks like it happens here again at x equals 4. And that looks like it's it, right? Well, then it has minimums where it goes from negative to positive. So negative to positive happens at x equals 2. See right here, we're decreasing and then we're increasing. And then it looks like it does it again over in this direction. So that happens at x equals 8. So the parts where it's increasing and decreasing, we can just simply pick it off of this chart over here. I'll just do the increasing one. So it's increasing on the intervals of what? -infinity to 4. Alright. And it's also increasing on the interval from 2 to 4. Excuse me, that's a -4 in the above example. And then where else is it increasing? It's increasing again at 8. So from 8 to infinity, it's increasing as well. Okay, so now for the points of inflection. Alright, well, keeping in mind that this is the derivative, so the slope of these tangent lines are going to tell me what the second derivative's values are going to be. So here, all of our tangent lines are negative. They're negative here until it gets to here. So here, since we have a horizontal tangent at -1, the second derivative has a possible point of inflection at x equals -1. And then the slope of this starts turning positive. It's positive until it gets to, looks like x equals 3. we go from positive and then we shift back down to going negative for our tangent lines. And then we have another horizontal tangent at x equals 6, possible point of inflection. So let me go ahead and complete this chart. We have negatives over here, we have positive tangents over here, all the way, looks like forever. So, looking at the sign of the derivative, the second derivative, we go from negative to positive, so that's definitely a point of inflection. And at x equals 3, we go from positive to negative. And then again, at 6, we go from negative on the left side to positive on the right side. So in fact, all three of these are points of inflection. Now when is this thing concave up? Well, when the second derivative is greater than 0, we know it's concave up. So that happens between negative 1 and 3. So negative 1 to 3. You can do something like this. And then again, it's positive from where? Between 6. And then it looks like it continues to infinity over here. So that's the points where it's concave up. And when it's concave down, the second derivative is less than 0. And that happens from negative infinity to what? To negative 1. Just erase that. Fix that. So from negative infinity to negative 1, it's concave down, and also it's negative from 3 to 6. Positive 3 to 6. And that looks like the only parts where it's concave down. So just make sure that when you're doing these type of problems, you really pay attention as to what they're giving you in the initial graph, and they're giving us the derivative, so we have to be able to interpret it both back towards the function like we did in part A, B, and C, and then looking at its derivative tells us points of inflection and also the concavity. Alright, well, hopefully this makes sense, and we will practice a few more.